Hello everyone, I am Siksha from BSc Chemistry Honors final year. Today I am read the chapter Acid and Bases. Now first Arrhenius concept of acid and bases. Arrhenius, a Swedish chemist, was the first to define acid and base in aqueous solution. According to Arrhenius, an acid is defined as a substance which contains hydrogen and which when dissolved in water gives hydrogen ions, that is H positive ions. Accordingly, all mineral acid like HCl, HNO3 and H2SO4 containing hydrogen when dissolved in water dissociate completely into hydrogen ions. एग्जाम्पल जैसे दिखा रखे हैं HCl कन्वर्टेड इनटू H पॉजिटिव प्लस Cl नेगेटिव इन द प्रेजेंस ऑफ वाटर. Same as HNO3 gives H positive and NO3 negative and H2SO4 gives 2H positive plus SO4 2 negative ions. Arrhenius named these acids which dissociate completely in water as strong acid. There are other acids like acetic acid CH3COH, carbonic acid H2CO3 and phosphonic acid H3PO4 which when dissolved in water do not dissociate completely into ions. As a result, an equilibrium is set up between the ions and the undissociated acid molecules as shown. CH3 in presence of water to give H positive plus CH3CO negative. H2CO3 gives 2H positive and CO3 2 negative. H3PO4 gives 3H positive plus PO4 3 negative. Arrhenius named these acids as weak acid. According to Arrhenius, a base is a substance which contains hydroxyl group and which when dissolved in water gives hydroxyl ion. The substance like NaOH and KOH when dissolved in water dissociate completely to give hydroxyl ion, that is OH negative ion, as NaOH in presence of water to give Na positive plus OH negative and KOH gives K positive plus OH negative. Arrhenius named these bases which dissociate completely in water as strong base. These are the substances which do not completely dissociate into hydroxide ion. Arrhenius named these substances as weak base. For example, substances like NH4OH, MgOH ki twice, AlOH ki thrice do not dissociate completely to give OH negative ions and can be written as NH4OH gives NH4 positive plus OH negative ion, MgOH ki twice gives Mg2 positive and 2H negative ion, AlOH ki thrice gives Al3 plus 3OH negative ions. Hydrogen ions obtained from the acids and hydroxyl ions obtained from the bases combine together to form unionized water. Arrhenius described this combination of H positive and OH negative ion as neutralization reaction. Example है NaOH gives Na positive plus OH negative and HCl gives H positive and Cl negative. Combine right hand side combine कर देंगे तो यहाँ से this and finally the reaction H positive plus OH negative ion to gives H2O, that is neutralization. Arrhenius concept is very simple to apply and explain a number of phenomena like neutralization, hydrolysis of salt, strength of acid and base. However, there are certain limitations which are described below. Arrhenius concept of acid and bases is applicable only in aqueous solution. This concept fails to explain the acid or base behavior of substances in non-aqueous medium such as liquid ammonia, liquid sulfur dioxide, alcohol, etc. Arrhenius concept fails to explain the acidic character of substance like CO2, SO2 and SO3 etc. and basic character of substance like NH3, Na2CO3, CaO etc. Arrhenius concept also fails to explain the reaction between an acid and a base in the absence of water. For example, NH3 plus HCl to give NH4Cl, Na2O plus SO3 to give Na2SO4. Although Arrhenius concept of acid and base suffer from a number of limitations, yet the concept is very useful and informative for an elementary approach. Now, second concept is Bronsted-Lowry concept. Arrhenius concept of acid and base was further improved by Bronsted and Lowry. Both Bronsted and Lowry gives the same definition for acid and base. According to Bronsted-Lowry concept, an acid is a substance which can donate a proton, whereas a base is a substance which can accept a proton. In other words, an acid is a proton donor whereas a base is a proton acceptor. As a result, Lowry-Bronsted concept is sometimes called proton donor acceptor concept. It can be represented as acid 1 to give H positive plus base proton donor and base plus H positive acid to proton acceptor. According to Bronsted-Lowry, a neutralization reaction involves the release of the proton by an acid and the acceptance of that proton by a base. For example, the reaction between HCl and NH3 to form the salt ammonia chloride can be represented as this. You can see Bronsted-Lowry base and Bronsted-Lowry base. दोनों बेस से आते हो. The curved arrows show how electron must rearrange to result in the transfer of hydrogen from atom the acid to a base. The unshared pair of electrons on the nitrogen of ammonia is attracted by the partial positive charge on the hydrogen in the polar hydrogen chloride molecule. A comparison of the structure of the reactant and product shows that the hydrogen atom which was bonded to chlorine in the reactant is bonded to nitrogen in the product. Thus, a proton has been transferred from chlorine to nitrogen. To act as a Bronsted-Lowry base, a spice must have at least one unshared pair of valence electrons so that it can form a covalent bond to the proton. To act as Bronsted-Lowry acid, a species must contain at least one hydrogen atom that is attached to an atom that is more electronegative than hydrogen. In this case, HCl loses a proton